All right, hello there. Well, we have our lesson today, and what we've talked about so far in this chapter is a couple of different things. We talked about the basic power rule for finding derivatives. We talked about finding the derivative of sine, finding the derivative of cosine. What today is, it's a couple more rules for finding derivatives. We haven't really talked about what happens if we have two different functions being multiplied together, and we haven't talked about what happens if we have two different functions being divided. And we can't just apply our normal power rule to those situations. So, as you've been doing your work, those things haven't shown up yet, and now here they are. So a couple new rules on finding derivatives. And then next class we'll have basically our last rule for finding derivatives, which is what this whole chapter is all about. So I was going to go through all this kind of exploration, but what I'm going to tell you is this, is if you have two functions being multiplied, like this one right here and this one right here, you cannot just find the derivative of each one of them and then multiply the derivatives together. That's the thing you're not allowed to do, and that's what this thing up here was going to show. Okay, so if you have two functions of x being multiplied together, there is a product rule that we then have to use. Okay, so here's our product rule, and then I'll do a couple examples using it. So if you're wanting to find the derivative, this is the notation for finding the derivative of a product of two different functions. Here's how we do it. We take the first function, whatever it is, times the derivative of the second function. So first times derivative of the second, plus then we take the second function, whatever it is, times the derivative of the first function. So that's our product rule right here. It's first times derivative of the second plus second times derivative of the first. That's our product rule. So anytime we're taking the derivative of a product of two functions in terms of x, we have to use the product rule. So I look at example 1, and technically we have options when we find derivatives sometimes. Like we could FOIL this out or distribute this all out and find the derivative term by term, and you'd get the correct derivative. But we're going to go ahead and use the product rule to do this. So f prime of x equals the first function times the derivative of the second function. So the derivative of the second function using our normal power rule, well, this would become 3x squared, and the derivative of negative 2 is 0. It's gone. So this is first times derivative of the second, plus then it's second times the derivative of the first. Well, the derivative of this first function would just be 6, because the derivative of 6x is 6, and the derivative of 5 is 0. It goes away, so times 6. We're going to get into a lot of AP tips throughout this class, but one of them is if as soon as you find the derivative using your rules, if that's all you're asked to do, you're done. You don't have to distribute. You don't have to clean up. This would be your final answer. We would leave this alone, and we would move on with our lives. What you're going to have to do, for your homework and for multiple choice questions is know how to manipulate correctly and, distribute and things like that. You'll get that practice in the assignment. I would make sure as you're doing the homework, not only can you use these rules, but you can also do the manipulation to get to the final answer. There's going to be some factoring you need to do and stuff like that in the assignment. So we'll go over that next time. All right, example 2. So we first have to recognize it's a product. When the problems come along, they're not going to say, warning, this one's product rule. Like you're going to have to keep in mind when to use product rule, which, the rule itself is not hard, but recognizing and remembering that you need to do it when needed is the hard part. So we have two different functions in terms of x being multiplied together, product rule. So this notation is the derivative of y with respect to x, like in terms of x. That's what this stands for here. So dy dx equals, and it's going to be the first function. Remember, the square root of x is same as x to the 1/2, and that's how we'll want to write it. So first times the derivative of the second. The derivative of cosine is negative sine. So that's first times derivative of the second. And then plus the second function, which is just cosine, times the derivative of the first function, which is going to be 1/2 x to the negative 1/2. Remember, power goes out in front, reduce the power by 1. And that would be it. We'd leave that sucker alone, and we would move on. So first times derivative of the second plus second times derivative of the first. All right, one more product rule. So again, it's important to recognize when we have to use product rule and when we don't. You know, this says find the derivative. Well, if I look here, this first term, we have to use product rule because we have two functions in terms of x being multiplied. This thing here, 2 sine of x, we technically don't have to use product rule because there's not two functions in terms of x, which we'll talk about here. So we're going to do product rule on 2x cosine x. That's how I'm going to start. So right now I'm just finding the derivative of 2x cosine x. So it's going to be first function times the derivative of the second function, which is negative sine, plus the second function, which is cosine, times the derivative of the first, which is just 2. So I'm going to put the 2 out in front here. So this is just the derivative of this underlined part. This is me doing the product rule for 2x cosine x. Now I need to do the derivative of minus 2 sine of x. Well, the derivative of minus 2 sine of x is minus 2 cosine of x. The number stays there, and we just take the derivative of sine of x, and it's cosine of x. So this one was product rule, the second one was not. And now I just clean it up. 2 cosine minus 2 cosine, those cancel. Whoop, gone. And then this is just negative 2x sine of x. Product rule. We did it. We're awesome. All right. The next one. Quotient rule. So I'll forewarn you, this one looks a little messy, but once you do it a handful of times, you'll have it down. I've never not had someone know how to use the quotient rule by the end of this lesson or by the end of doing the homework assignment. So it looks a little messier, but just bear with me. So anytime you're taking the derivative of a fraction, a quotient, again, you can't just take the derivative of the top and then the derivative of the bottom and divide them. You can't do that. It's not going to work out and give you the correct derivative. Instead, here is our quotient rule. So if we want to take the derivative of a fraction, it's going to be the bottom function times the derivative of the top function. So bottom times derivative of the top minus, so minus on this one, the top function times the derivative of the bottom function. And then all divided by whatever the bottom function is squared. Maybe good notation would be to put brackets around there. So there it is. Bottom times derivative of the top minus top times derivative of the bottom over the bottom squared. There's a little mnemonic device, someone told me a long time ago, and it was this. It was low d high minus high d low over low low. Low d high, so basically low is the bottom, so low d high, derivative of the high, low d high, minus high d low over low low. And so if you just remember, it starts with low d high minus high d low over low low, you'll be in good shape. In fact, I'll have kids be taking a quiz, and I'll hear them kind of whispering that as they're doing it. Low d high minus high d low over low low. And now let's put it in action. So we have a fraction. I want to do the quotient rule here. So it's going to be low d high. So the derivative of the top is 2x minus high d low, so the derivative of the bottom is just 2 over low low. So low d high minus high d low over low low. Make sure we don't make some silly algebra mistakes here. One thing I see students do sometimes is they'll take this and they'll cross one of these out. They'll think, oh, these are both in parentheses. I'm just going to go ahead and cross one out. Well, you can only cross things out that are factors, things that are being multiplied to everything. This 2x minus 7 right here is not being multiplied to all this stuff over here, so it's not a factor of the numerator. It's not something you're allowed to cross out. So don't make silly mistakes like that. And that's it. I would just leave my answer like that, and life goes on. But again, on the homework, I would make sure you're getting to the final answer through algebra manipulation, stuff like that, just to match the multiple choice answers. But there it is. All right. Next one. So we have a fraction. Let's find its derivative. I'm going to find you derivative. No, you won't. Yes, I will. All right, so low, d high, minus high, d low, so the derivative of t cubed is 3t squared, over low, low. So t cubed squared, using some algebra rules, if I had t cubed squared, that would be t to the 6th. That's sloppy math, but I wanted to show you where I was going with that. Now, what you might have to do, again, to match the multiple choice, you might have to factor things on top to get things to cancel out with the denominator. And here's what I mean by that. If you notice, both of these terms have t's in them. In fact, this has t cubed, and this has t squared. We can actually factor out t squared from each of these. I haven't cleaned up any of the others, and I wanted to show one being done here. So if I factor out, and in fact, since both terms are going to end up negative, see how this is negative and negative, you might be good taking out a negative t squared to make all the signs positive. This is just some algebra fun. So this is now going to be positive. You're going to have a t left, sine of t. And then this is going to be a plus, because we're taking out a negative. And then we took out t squared, so that's gone. So it's just 3 cosine t. Over t to the 6th. Whoops. And now we'd be able to cross out t squared from each of these. So gone, and there'd be 4 of these left. So negative t sine t plus 3 cosine t over t to the 4th. Again, if this is a free response question, I would stop here at the very first step. I wouldn't keep going. But like I said, you may have to match an answer, and so just knowing some of that algebra can help you get to the correct answer. So I wanted to show one where that could happen. All right, the last one. So I mentioned how we should know the derivative of sine and cosine. Like, you should have those down. The derivative of sine is cosine. Derivative of cosine is negative sine. Okay. You're also going to have to know the derivative of the other 4 trig functions. So tangent, cotangent, secant, cosecant. These are just 6 trig derivatives you're going to want to have memorized. Okay. Now, the reason I have tangent here as an example is this. By the end of this lesson, you should know the derivative of tangent is blank. I'm not going to spoil it for you. But I want to show you that you can actually find the derivative of these other 4 trig functions just by knowing the derivative of sine and cosine. So I want to show how, let's say you're taking a quiz and you're like, oh crap, I don't remember the derivative of tangent. You can do this instead. This is an option that you have. First of all, tangent is sine over cosine. That's what tangent is. It's sine over cosine. And so let's say I want to go through and the quotient rule and find the derivative of this, okay? So I'm going to go through the quotient rule to find this. So it's going to be low, d high, so the derivative of sine is cosine, minus high, d low, over low, low. And remember, when you square a trig function, it looks like this. Right there. Now let's clean this up just a tad. So this is going to be cosine squared. This is going to be positive sine squared. Now you cannot cross cosine squared out because cosine squared is not a factor. Don't be an algebra silly mistake maker. But going back to pre-cal, sine squared plus cosine squared, this identity, this equals 1. So this is the same as 1 over cosine squared. And then 1 over cosine squared is just secant squared. Remember, 1 over cosine is secant, so this is just secant squared. Now, the point of all this is just knowing that the derivative of tangent is secant squared. Like, that's just something that if you know, then you can avoid all of this mess here. But if you're taking a quiz and you don't remember the derivative of tangent, this is an option that you can do. It's always nice to have options, okay? So the derivative of tangent is secant squared. So that leads me to all these. I'm just going to write these out. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent, as we just found out, is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent. The derivative of secant is secant tangent. And the derivative of cosecant is negative cosecant cotangent. I had a student a year or two ago tell me a trick they learned from YouTube on trying to memorize these, which I actually found it to be pretty helpful, to be quite honest, is she said, if you write out secant, secant, tangent, like if you write this phrase out, secant, secant, tangent, whichever one you want to find the derivative of, just cover it up, and you're left with the derivative. Like, if I want the derivative of tangent, if I cover up tangent, it's secant squared. If I want the derivative of secant, cover up secant, and it's secant tangent. So this will actually find you the derivatives, this little mnemonic device here. Same for the other ones. The other one you can, for the co-functions, it's negative cosecant, cosecant, cotangent. It's kind of similar pattern there, just negative and then the co-functions. And then whichever one you want to find the derivative of, just cover it up. So I found that to be pretty helpful. All right. So you're going to go on and take the AP Classroom quiz over product and quotient rule. This right here, guys, was a lot of the college calculus that I kind of talk about, the algebra, the actual functions and trig. What you're going to find on the AP test is they'll have you do these rules, but in different ways. And I think it's important to see both sides of the coin. So I want you guys to work on the product quotient rule quiz. You can work with someone else. And try to get your best score, and we'll talk about them. All right. Good luck, and let me know if you have any questions.